5 reasons why teachers are teaching PEMDAS the wrong way. PEMDAS is an acronym that stands for parenthesis, exponents, multiplication, division, addition, and subtraction. It is a set of rules of operation, used when working on formulas or equations. It is flooded with several operands, like plus, minus, cross, obelus, and exponent, that are used in solving problems in math, physics, and higher specialized subjects. It was developed so that everyone in the fields of science, mathematics, and technology will have the same set of rules in dealing with operations, numbers, and equations. However, according to J. Lawson, author of Originimology, PEMDAS is not rationally, mathematically, and scientifically watertight, and it needs to be revised at least to its minimal capacity so that first-time learners will enjoy the beauty and elegance of its operations. Lawson claimed that PEMDAS is incorrect because of the following corroborating evidence. Proof number 1. The operators, plus, minus, cross, obelus, and exponent, produce a fixed result. They add, subtract, multiply, divide, and raise numbers, respectively. When engaged mathematically, they provide some answers. However, a parenthesis does not produce any answer or result at all. It acts only as a simple holder of numbers and variables inside its brackets. For example, when we add 4 plus 5, it gives us 9. 9 minus 8 gives us 1. 8 divided by 4 equals 2, 7 times 3 equals 21. And 6 raised to the power of 2 equals 36. All the operands on these notations or expressions produce some kind of result. But when we put a number inside a bracket, like 4, the parenthesis is not doing anything except that it is just embracing the number inside its cell. It does not or cannot produce an outcome. Now, if we consider the parenthesis as a property of identity, where it carries an exponent of 1, and becomes a part of the exponential family, then the parenthesis can now produce a result. Like, when we raise it to 0, it produces a result equivalent to 1. Thus, PEMDAS can now be rearranged logically as EMDAS, but of course, EMDAS is still wrong, as you will see later. Proof number 2. MDAS is the forerunner of all mathematical operations. They are the first 4 operands we learned at an early age in our lives. They are the first 4 original operators we loved to play with numbers when we were studying math. Then we progressed to exponents and factorials. Because of this primary progression from simple to more complex operations, we can place MDAS first in the order, and add the E last, as in MDASE. Proof number 3. Aside from the magnificent 4, plus the exponent, another essential operand must be added to the orders of mathematical operation. This is the factorial operand represented by the exclamation point. A factorial also generates a result, like 0 factorial is equal to 1. Thus, if f is added to the series, then the complete order of operations now becomes MDASFE. Proof number 4. Scientifically, when we solve for x in a non-numbers all variables equations, we usually simplify the equation first. We find the formula for x. Once simplified, we now solve the value of x. To compare which is better, between PEMDAS versus MDASFE, let us use this simple equation. d times x equals m times open bracket, square root of n, plus 0 factorial, close bracket, raised to the power of 2. Using PEMDAS, d times x equals m times open bracket, square root of n, plus 0 factorial, close bracket, raised to the power of 2. d times x equals m times open bracket, open parenthesis, square root of n, plus 0 factorial, close parenthesis, times, open parenthesis, square root of n, plus 0 factorial, close parenthesis, close bracket, d times x equals m times open bracket, square root of n, times open parenthesis, square root of n, plus 0 factorial, close parenthesis, plus 0 factorial, open parenthesis, square root of n, plus 0 factorial, close parenthesis, close bracket, d times x equals m times open bracket, open parenthesis, square root of n, times, square root of n, close parenthesis, plus, open parenthesis, square root of n, times, 0 factorial, close parenthesis, plus, open parenthesis, times, square root of n, times, 0 factorial, close parenthesis, plus, open parenthesis, 0 factorial, times, 0 factorial, close parenthesis, close bracket, d times x equals m times open bracket, n, plus, square root of n, plus, square root of n, plus 1, close bracket. D times x equals m times open bracket, n, plus 2 square root of n, plus 1, close bracket. Therefore, x is equal to m times open bracket, n, plus 2 square roots of n, plus 1, close bracket, divided by d. Notice that we use the e, which stands for exponent, in PEMDAS. The p is in stalemate mode. The term stalemate mode, or equation freezes, was coined by Lawson to describe an equation where it can no longer be solved without deviating from the rules of operations. Now if we use MDASFE, the solution will be faster and easier. Thus, again, if we use the original equation, d times x equals m times open bracket, square root of n, plus 0 factorial, close bracket, raised to the power of 2. By following the order of multiplication and division, instead of parenthesis and exponent, yields us to x right away, where x is now equal to m times open bracket, n, plus 2 square root of n, plus 1, close bracket, divided by d. Notice that we use here the d, which stands for division, in MDASFE. The solution of the equation is also simpler and shorter compared with PEMDAS. And finally, if we compare PEMDAS to MDASFE using an all numbers variables equation, where m equals 3, n equals 4, and d equals 9, then the solutions are as follows. For PEMDAS, 9x equals 3, square root of 4 plus 2, times square root of 4 times 1 plus 1 to the power of 2. 9x equals 3, 4, plus 2 times square root of 4, plus 1. 9x equals 3, 4, plus 2, times 2, plus 1. 9x equals 3, 4 plus 4 plus 1. 9x equals 3, times 9. 9x equals 27. X equals 27 divided by 9, x equals 3. For MDASFE, 9x equals 3, square root of 4 plus 1, raised to the power of 2. 9x equals 3, times 2 plus 1, raised to the power of 2. 9x equals 3, times 3, raised to the power of 2. 9x equals 3, times 9. 9x equals 27. X equals 27 divided by 9, x equals 3. Due to all these rational, mathematical, and scientific pieces of evidence, PEMDAS should now be abandoned, and replaced instead, by MDASFE. Let us simplify MDAS forever. The rebuttal on this video is an excerpt published by Joey Lawson in his books Originimology, The Science Behind the Beginning of Everything, and Autognorix, The Science of Engineered Lifeforms. Thank you for watching, and don't forget to subscribe, share, and like.